That is not true for discrete. Okay, for continuous, that is actually true. And take a look at this. The probability of S less or equal to A. Less or equal to A, you are trying to say at most A. The upper bound is going to be A. And the lowest of the lowest, of course, that's going to be infinity, negative infinity. And that's why you have that. Okay, I'm going to move. Now, I want to get into an example right now. Take a look at this guy now. Okay, suppose that the error in the reaction temperature. Of course, let me tell you, we got so many examples of continuous random variable. When you talk about an economy, talk about asset price, talk about return. When you talk about changing demand and supply, and when you come all the way to maybe scientific liability, you talk about temperature, you talk about even in a medical line, you talk about like blood pressure, in a pharmacokinetics, you talk about the concentration in the drug level, a lot of stuff like that. You actually they can be modeled using a continuous random variable. So take a look at this guy. Okay, it said in a control laboratory, the continuous random variable S has the following probability density function. We're talking about error. Please, I need you to pay attention now. Okay, error can be made in a stochastic environment, and this very error can be modeled, okay, by a probability function. Okay, you know what this guy is trying to tell me? The test space say, the error we can make is going to be between -1 and 2. That's what it means. And this is a mathematical representation of that particular reality. Okay, now if I want to work on this, I need to four of us investigate. I need to four of us verify. Is this the first axioms, whether it's okay, f of s greater or equal to 0? Let's see. If I choose a value within this and I plug it in, does it going to give me positive? Yes, because this is squared. Does that make sense? And that's confirmed this guy. Okay. Now the next thing is I want to talk about the validity. The validity is you can see the general formula here, negative infinity to infinity. You are not going to use negative infinity to infinity here. You're going to make sure you pay attention to the state space given in the question. Okay, so right now, do you know that it is only when I know that this guy is correct, okay, that I will be able to find this. Now, if you want to investigate that guy now, what you actually going to do, this is the proof. Okay, I know the general formula is negative infinity to infinity, but I'm actually going to use the formula, the state space, which is going to be from -1 to 2. So -1 to 2, you just need to integrate that, then you plug into a -1, then the moment you have 1, then you have already validated the density function. Now let me tell you this. When a probability function is not validated, if it is continuous, if the total area under a curve is not equal to 1, you know what you're trying to say? Then you are trying to say you are not ready to make a probabilistic decision in a stochastic world. Because if you want to make a probabilistic decision in a stochastic environment, you need to understand possibility. When the total area under a curve equal to 1, then it means you've considered all possible outcome in your sample space. Does that make sense? Any question here? Any question? Like I said, you need to revisit your knowledge of calculus in this case. Okay, now this is the picture. Okay, if I want to sketch that now. So how do we sketch this? In the x-axis is -1 to 2. Okay, and what I'm trying to say, when you plug in -1, plug in some values, and you plot that, this is what you're gonna have. Okay, that is what you're gonna have. Now, the moment you get that, we can now take a, what we're trying to do here. This is a probability query. This is like providing answers to some practical problem. Okay, we want to find the probability of x lie between 0 and 1, error, the lie between 0 and 1. It's going to be a truncation, right? It means I'm not using the total area under a curve, because the state space actually start from -1 to 2. So it is expected that whatever I'm going to get here should be less than 1. That's why you have that. Okay, that's less than 1. Okay, and if I want to explain this to a psychologist or sociologist or somebody that is not in mathematics or statistics, what does it mean? Okay, if I really want to, I'm gonna say, okay, you know, if night, I'm gonna say 9 of a time, the error is gonna be between 0 and 1, only 1 out of 9 times. That's what this one is talking about. If you want to know in terms of percentage, multiply by 100 to be able to know the percentage of time. The error can be between this and that. That's what we're talking about. Probability is kind of easy, provided you understand what is behind the scene. Now, that is a picture for that. Okay, now I want to go into another properties of, a random variable. We call it a CDF. The CDF means cumulative distribution function. And I need you to pay attention now. The PDF, we use a lowercase. We use this. Okay, for PDF. We use an uppercase for CDF. Okay, please, I need you to pay attention. This CDF, what it basically means, okay, is the probability of a random variable less or equal to a particular value. Okay, maybe we started a restaurant, or maybe you started a restaurant in maybe on campus, and you actually want to know what is the probability that we're going to cumulatively make maybe $5,000 within 4 days of operation. That's a CDF. Or in survival analysis, okay, we are managing some patient. Okay, what is the probability that the patient will survive up to a particular numbers of years? Of course, if I want to talk about survivor, like, do you know the complement of this guy? The complement of this guy, okay, one minus this guy now is actually this. Does that make sense? That's a complement, right? Oh, let me write that. That's a complement, right? Take a look at that. Okay, maybe I want to know, what is the probability that somebody who is diagnosed with a disease, okay, will live longer than, if I really want to know, I can make use of my CDF. So by CDF, what we actually mean, take a look at, that's what we mean, the probability of a random variable as less or equal to a realized value. Within that, okay, now mathematically speaking, okay, we're actually going to consider what you see here. Okay, what you're going to see, even though I'm working, I know the PDF is f of s, a lowercase f of s, but because the upper bound here is x, the upper bound is x, the lower bound is that, then I'm not going to say f of s. I can say f of t or f of m, or do you understand what I mean? So this f of t is more or less f of s. Do you understand? Because the uppercase it says so. That's the way we put it. Okay, do you know with the CDF, it will enable us to find the probability of that? Okay, for instance, I want to find the probability of S lie between A and B. It is the same thing as the probability of S less or equal to B, the minus S less or equal to A. And do you know that each of these, okay, is a CDF? Okay, this guy, if take a look at this guy, look at this definition here. Automatically, this guy is actually going to be f of B, an uppercase f of B, and this guy automatically going to be an uppercase f of A. Go ahead.
So with the PDF, is it a lowercase p for the probability? And with CDF, it's uppercase p?
No, it's the what distinguishes between PDF and CDF is lowercase f for PDF, uppercase f for CDF, but this guy here still remain the same thing. Does that make sense? That's a good question. Okay, now I'm going to move right now. Now, in the example that we've done, okay, what if I ask you to find CDF, and I ask you to use the CDF to find that? Without CDF, we can still find this. We found this before, but the idea of CDF can also be used to find it. I told you the other time, we got so many ways, to figure out a probability question. Now, I need you to pay attention now. You are given F of S. This is a PDF, right? I want to find CDF. What am I going to do? What is definition? If I want to find CDF, what I'm going to do is I'm actually going to start from the lower bound given in the question to a particular point that I may call X. What is the lower bound given in the question? Please pay attention. -1. Whatever lower bound given in the question.